Welcome back. It is January 20th, 2026, and if you have been following the interstellar anomaly known as 3I Atlas, you understand that we have been anticipating a significant development, something that would either confirm our suspicions or put them to rest. That development has now arrived, and I have to be direct with you. The data we are examining tonight does not merely challenge our existing models, it fundamentally breaks them. This is not an incremental update. This is a paradigm shift. Let us begin with what the Hubble Space Telescope has just revealed. New images captured 5 days ago on January 7th have confirmed a feature that astronomers had only speculated about in private conversations until now. These are not grainy, ambiguous photographs open to multiple interpretations. We are looking at a high-resolution composite of this interstellar visitor, constructed from multiple exposures and processed through the most advanced imaging techniques available. And clearly visible in the frame is something that, according to everything we know about cometary physics, should not exist. A sharp, coherent structure, a powerful, narrow jet aimed directly at the Sun, not angled toward it, not vaguely pointed in its direction, directly at it. Within the framework of standard cometary physics, this feature is impossible. I do not use that word lightly. In science, we try to avoid absolute statements, but the physics here is unambiguous. Let me explain why this should not be happening. Comets, as we have understood them for centuries, are essentially dirty snowballs, mixtures of ice, dust, and frozen gases that heat up as they approach the inner solar system. As they warm, they release material through outgassing. This material forms the characteristic tails we associate with comets, but those tails obey specific rules dictated by two fundamental forces. The first is solar radiation pressure, the literal pressure of sunlight pushing against dust particles. Photons carry momentum. When they strike small particles, they transfer that momentum, pushing the particles away from the sun. The second is the solar wind, a continuous stream of charged particles flowing outward from our star at hundreds of kilometers per second. These particles collide with cometary material and sweep it away from the sun. Both forces work in the same direction. They push material away from the sun. This is not a suggestion or a tendency. It is a fundamental rule that has held for every single comet observed since humans first pointed telescopes at the sky. Every comet, every observation, no exceptions until now. 3I Atlas is violating that rule in the most extreme way imaginable. This new jet is what we might call an anti-tail, but that term does not capture the magnitude of what we are seeing. This structure is moving directly into the solar wind. It is fighting upstream against radiation pressure and, against all expectations, against everything our models predict, it is winning. The material in this jet is maintaining cohesion while traveling in a direction that every force in this region of space is trying to prevent. The jet extends approximately 400,000 kilometers from the nucleus. Let me put that number in perspective because raw numbers can lose their impact. The distance from Earth to our moon is about 384,000 kilometers, the farthest humans have ever traveled from our planet. The Apollo astronauts crossed that gulf in 3 days. This jet of material stretches farther than that entire distance. It spans the gap between two worlds, and unlike a diffuse cloud that would be expected to disperse, it maintains its structural integrity against forces that should be tearing it apart and scattering it within hours. This observation contradicts what we previously understood about how such objects behave. When hints of this feature first appeared in the July 2025 data, there was hope among researchers that it might be a projection effect, an optical illusion caused by our viewing angle. The geometry of how we observe objects in space can sometimes create misleading impressions. Two-dimensional images of three-dimensional structures can make features appear to point in directions they actually do not. Perhaps the jet was actually pointing in a different direction and only appeared sunward because of perspective effects. That hope has now been definitively eliminated. Multiple observations from different angles over several months confirm that this jet is genuinely oriented toward the Sun. Parallax analysis rules out projection effects. There is no trick of perspective here. There is no viewing angle explanation that resolves the anomaly. The feature is real and it is aimed precisely where it appears to be aimed. Using the Larsen-Sekanina rotational gradient filter, an image processing technique designed to reveal subtle contrasts in cometary structures, astronomers have discovered that this sunward feature is actually the dominant component of a more complex system. There are 3 jets total, but while the other 2 are faint and diffuse, this sunward spike is tightly collimated. It is not fanning out like a spray. It is maintaining focus like a beam. Think about what that implies. To maintain a structure that is 10 times longer than it is wide while plunging toward the Sun against all the forces trying to scatter it requires specific conditions. The material in that jet must be moving at a significant velocity. It must have a density that we do not observe in natural evaporation processes. The physics simply does not work otherwise. So what does this actually mean for our understanding of this object? It means we must discard what scientists call the passive comet hypothesis. A passive body, one that is simply reacting to its environment without any internal mechanism driving its behavior, does not produce features like this. If this were simple sublimation, ice transforming directly into gas as it heats, the gas would expand in all directions, or at least in a broad cone toward the Sun before being swept backward by the solar wind. That is how thermodynamics works. Gas expands. It does not focus itself into a beam. What we are observing is an outflow that remains focused over hundreds of thousands of kilometers. This suggests a nozzle. It suggests a constrained release of energy or matter that somehow remains impervious to the standard environmental pressures of the inner solar system. The brightness of this jet creates another puzzle. At the current distance from the Sun, this feature is inexplicably luminous. If the jet were composed of standard cometary dust, the solar wind should be stripping away the smaller, brighter particles first. These lightweight particles are most susceptible to radiation pressure. What should remain are heavier, darker grains that would produce a faint, barely visible tail. Instead, the feature remains brilliant and sharply defined. This suggests one of several possibilities. Either the particles within the jet are incredibly heavy, massive enough to resist being swept away by radiation pressure, or they are being replenished at a rate that is frankly staggering for an object of this estimated size. Neither explanation fits comfortably within our existing models. Here is the detail that makes this situation even more significant. This jet was already visible in July of 2025. That means this phenomenon is persistent. It is not a momentary outburst caused by a sudden fracture in the surface. It is not a temporary event triggered by thermal stress as the object approached the Sun. This is a continuous, stable state that has persisted for months. We are observing something that has maintained a precise orientation relative to the Sun despite the object's movement through millions of kilometers of space. Think about the control that implies. The Sun is not stationary from the object's perspective. As 3I Atlas travels along its trajectory, the direction to the Sun constantly changes, yet this jet tracks that changing direction perfectly. In a natural scenario, a rotating cometary nucleus would spray material in a spiral pattern. Imagine a garden sprinkler rotating while water shoots out. The water forms a spiral as the sprinkler turns. That is what we expect from rotating objects releasing gas. To have a straight jet that consistently points toward the Sun from a rotating body requires something special. The source of the jet must be effectively locked to what astronomers call the subsolar point, the spot on the surface where the Sun appears directly overhead. As the object rotates, that point moves across the surface. For the jet to stay aimed at the Sun, either the object is not rotating, which we know from brightness variations is false, or its rotation has a very specific relationship with its orbital geometry. This brings us to the orbital dynamics and spin state of 3I Atlas, and this is where statistical coincidences stop looking accidental and start looking like deliberate geometry. By tracking the subtle wobble of that sunward jet over recent months, astronomers have reconstructed the spin axis of the nucleus. Picture the object as a spinning top. Every spinning object has an axis, an imaginary line around which the rotation occurs. That axis points in some direction in space. For most objects drifting through the cosmos, that direction is random. There is no preferred orientation. The chaotic history of collisions and gravitational interactions that shaped these bodies left their spin axis pointing in essentially arbitrary directions. 3I Atlas is different. Measurements indicate that its rotation axis is aligned with the Sun to within approximately 7 degrees. This is an extraordinarily unlikely configuration. Let me explain why this matters. When an object enters our solar system from interstellar space, it brings whatever spin it had out in the void. The gravitational influence of our Sun is far too weak at these distances to significantly alter an object's rotation during the brief time it spends passing through. Whatever orientation 3I Atlas has now is presumably the orientation it arrived with. The probability of a randomly oriented object happening to have its pole pointed almost directly at our Sun is extremely small, but the improbability compounds further. Not only is the pole pointing at the Sun, but the object's trajectory, its path through our solar system, is closely aligned with the ecliptic plane, the flat disk where Earth and the other major planets orbit. Most of the solar system's mass and activity is concentrated in this plane. Interstellar objects can arrive from any direction. The first confirmed interstellar visitor, 1I Oumuamua, came in at a steep angle. The second, 2I Borisov, similarly dropped in from well above the plane. They cut through the solar system like needles through fabric, crossing the ecliptic and continuing on their way. 3I Atlas is different. It is sliding in almost perfectly flat. It is moving within the same traffic lane as the planets themselves. When you combine these two factors, a rotation pole pointing at the Sun and an orbit closely aligned with the planetary plane, the probability becomes vanishingly small. The combined geometry is improbable at better than 1 part in 10,000. In probability theory, when you encounter a 1 in 10,000 event, you face two interpretive options. Option 1 is that we simply won the cosmic lottery. Improbable things happen, someone eventually wins even the longest odds. Perhaps we are just observing the rare exception that proves the rule. Option 2 is that the underlying assumption of randomness is incorrect. If the alignment is not random, it implies a constraint. It implies that the object's orientation is somehow coupled to its trajectory or perhaps coupled to the Sun itself. This second interpretation contradicts everything we previously understood about interstellar debris. Debris is supposed to be chaotic, random. A tumbleweed blowing through the cosmic wind does not orient itself aerodynamically unless it has some kind of stabilizing structure. 3I Atlas is behaving as if it has such a structure, as if it has a fin. The specific alignment of the rotation axis creates a peculiar thermal situation. One hemisphere of the object is essentially in permanent daylight, the other is in permanent darkness. This is like a perpetual summer solstice that never ends, maximum heating concentrated on one pole continuously. If this were a natural comet, that constant heating might explain steady outgassing from one location. But remember the jet. The jet is not a diffuse cloud of gas. It is stable and narrow. If the pole is pointing at the Sun and the jet is emanating from the pole, then geometrically the jet is acting like a thruster firing along the object's line of motion relative to the Sun. The stability of this configuration is remarkable. If the object is non-spherical, as brightness variations suggest it is elongated, then outgassing should produce torques that cause the spin to accelerate or drift over time. This is called the Yorp effect, and it affects virtually all small bodies that release gas asymmetrically. Yet 3I Atlas maintains its sunward orientation. It keeps its jet, or perhaps we should say its nozzle, fixed on our star. This brings us to a question worth considering carefully. At what point does a series of statistical improbabilities stop being coincidence and start being evidence? We have a jet that defies physics. We have geometry that defies probability. Where is the threshold where natural explanations become less credible than alternative hypotheses? The precision of this alignment becomes even more significant when we examine where 3I Atlas is heading. It is not simply passing through our solar system and exiting into the void. It is on an intercept course. We are observing a set of initial conditions, spin, orbit, and jet orientation, that appear precisely tuned to facilitate a specific event in the outer solar system. The object is heading toward the gravitational domain of Jupiter, and the timing of its arrival is practically synchronized with optimal observation conditions. The alignment with the ecliptic plane makes a close encounter with a major planet far more likely than if the object had arrived at a steep angle. Objects that dive through the plane quickly have limited opportunity to interact with the planets. Objects that travel along the plane have maximum exposure. The calculations show an encounter that is remarkable in its precision. 3I Atlas will graze Jupiter's Hill sphere, the boundary where the giant planet's gravity begins to dominate over the Sun's influence. This boundary extends approximately 53.5 million kilometers from Jupiter. The object will pass at approximately 53.6 million kilometers. The margin is extraordinarily tight. This brings us to the hypothesis that has been circulating in astrophysics discussions, the Euphemy connection. Among Jupiter's many moons is a small, irregular satellite called Eupheme. It is tiny, only about 2 kilometers across. It orbits in what we call a retrograde direction, moving opposite to Jupiter's rotation in a region populated by captured asteroids known as the Ananke group. 3I Atlas will pass close to this region. Specifically, on March 17, 2026, just one day after crossing Jupiter's Hill sphere, the object will make its closest approach to the Eupheme orbital zone. There is a theoretical scenario, improbable but physically possible, where 3I Atlas could interact with this region in a meaningful way. If the object were to eject fragments during this passage, or if it were to separate into multiple bodies, the dynamics become interesting. We are discussing what scientists call a Hill radius event, an interaction occurring right at the gravitational boundary where Jupiter's influence takes over. If 3I Atlas remains a single coherent body, it passes through and continues into the outer solar system. But if 3I Atlas is something more complex, if it is carrying something that could be released, then this boundary represents a perfect delivery zone. But here is where the physics presents a fundamental obstacle. We need to discuss energy budgets. To convert a 66 kilometers flyby into a capture orbit requires an enormous change in velocity. Scientists call this delta V, and the delta V required here is massive. Jupiter is the largest planet in our solar system. Its gravity is immense. The escape velocity near Jupiter's cloud tops is approximately 60 km/s. But 3I Atlas is not skimming the cloud tops. It is passing 53 million kilometers out. At that distance, Jupiter's gravitational grip is much weaker. The escape velocity at the encounter distance is only about 2.2 km/s. This is the speed limit for becoming a moon. If you are moving faster than 2.2 kilometers relative to Jupiter at that distance, you are not captured. You are a visitor passing through. 3I Atlas is moving at 66 km/s. Subtract 2.2 from 66. The object is traveling approximately 64 km/s, too fast to be captured by Jupiter's gravity alone. For any part of 3I Atlas to remain in the Jovian system, it would need to shed that 64 km of excess velocity, essentially instantaneously. This contradicts what we understand about natural fragmentation events. When a comet breaks apart naturally, whether from rotational stress, spinning it apart, or thermal cracking as one side heats dramatically while the other remains frozen, the pieces drift away from each other gently. The forces involved are modest. Fragments might separate at 5 meters per second, perhaps 10. In the most violent outbursts ever recorded, events where subsurface volatiles explosively vaporize, fragments might receive a kick of 1 or 2 km/s. Those are extreme cases documented only a handful of times in the entire history of cometary observation. The energy requirements are genuinely staggering when you calculate them properly. Kinetic energy scales with the square of velocity. This is not a linear relationship. Doubling velocity quadruples the energy. To decelerate a fragment by 60 km/s requires an energy release comparable to a focused nuclear detonation, not a chemical explosion, not volatiles vaporizing, nuclear-scale energy precisely directed. The physics simply does not allow for this through any natural process we have ever documented or theorized. So what does this actually mean? It means that if we detect a new moon appearing in Jupiter's system after March 17, 2026, we are not looking at a natural phenomenon. Nature does not have braking thrusters. Nature does not perform orbital insertion burns. If an object separates from 3I Atlas and enters a stable orbit around Jupiter, that object had to execute a high-energy maneuver, a precisely directed velocity change, an impulse that canceled out the approach speed and dropped the fragment into a gravitationally bound trajectory. Remember the anti-tail we discussed earlier? That sunward jet proved the object has a mechanism for directed outflow. It proved the object can maintain a stable orientation. If that same mechanism is capable of a high-thrust event, or if the jet we observed was actually a braking burn performed early to fine-tune this arrival, the picture becomes coherent. This connects to theoretical concepts that have existed in scientific literature for decades. The Bracewell probe, the von Neumann probe, these are hypothetical autonomous spacecraft designed to travel between star systems and monitor what they find. A probe performing a flyby of a planetary system might deploy a subprobe. To deploy that subprobe at high relative velocity, you need a high impulse separation. The seemingly impossible velocity change required to leave something at Jupiter is precisely what such a deployment would require. If 3I Atlas departs our solar system intact, but Jupiter gains a new satellite, the laws of celestial mechanics tell us that satellite did not arrive there by accident. It would have to be placed there deliberately with precision. The statistical improbability of the alignment combined with the physical impossibility of natural capture creates a logical corner. The natural object hypothesis cannot easily maneuver out of this corner. We are forced to at least consider alternatives. The appearance of a new Jovian moon after this encounter would therefore be extremely difficult to reconcile with purely natural origins. It would represent a potential technological signature. Let me be precise about that term. Technological signature does not mean we have a photograph of a spacecraft. It does not mean we have received a radio message. It means we have data that cannot be generated by the normal background processes of the universe. Data that implies engineering. The 400,000-kilometer jet pointing upstream against the solar wind. That is a potential signature. The 1 in 10,000 geometric alignment, that is a potential signature. A captured moon appearing at Jupiter in March, that would be the signature. So what happens next? March 2026 offers a rare and potentially decisive observational opportunity. This is not speculation or distant future planning. We have instruments in position. The encounter will be monitored by ground-based telescopes around the world and by NASA's Juno spacecraft currently in orbit around Jupiter. Juno is the critical asset here. The spacecraft has been orbiting Jupiter since 2016. Its instruments have weathered nearly a decade of intense radiation exposure, but they remain functional. NASA has already adjusted Juno's observation schedule to account for this event. The spacecraft will not be close enough to 3I Atlas to image surface details, the distances involved are too vast, but Juno is perfectly positioned to detect the aftermath of any significant event. If 3I Atlas releases energy, if it fires any kind of thruster to decelerate a payload, Juno's waves instruments and magnetometers might detect the resulting plasma disturbance. Jupiter's magnetosphere is sensitive to perturbations. An energetic event at the Hill sphere boundary would likely produce detectable signatures. If a new object enters Jupiter's system, Juno's camera can search for it in the weeks following the encounter. We will be watching. This contradicts what we previously assumed about our preparedness for such events. Usually, interstellar objects pass through too quickly for comprehensive study. This time, we are waiting at the finish line with instruments ready. Here is the crucial point regarding what we might call a verdict on this situation. If nothing unusual happens, if 3I Atlas flies past Jupiter, remains intact, and continues outward into the void without leaving any trace, we will be left with a profound mystery, but it will be a mystery that can still be categorized as natural. We will have to rewrite textbooks about cometary jets and what geometric alignments are possible through random chance. 3I Atlas will be classified as an exotic comet, strange but natural. But if something stays behind, if Jupiter gains a new satellite that was not there before this encounter, then humanity faces a different situation entirely. We would transition from a species speculating about life elsewhere in the universe to a species studying an artifact deposited on our cosmic doorstep. The impossible velocity change described earlier would become proof of engineering. The technological signature would be confirmed. We are weeks away from what may be one of the most significant moments in astronomical history. Whether 3I Atlas proves to be an extraordinary freak of nature or a messenger from another star system, it has already secured its place in the scientific record. No object has ever presented this combination of anomalies. No previous visitor has challenged our models so thoroughly. The evidence has accumulated across every aspect of this object we have examined: the physics-defying jet, the statistically improbable alignment, the precision trajectory toward Jupiter, the capture physics problem that eliminates natural explanations for any material that might remain behind. Each piece of evidence individually could perhaps be explained away with sufficient creativity, but together they form a pattern that demands serious consideration of possibilities we have previously dismissed as speculation. The scientific method requires us to follow evidence wherever it leads. It requires us to update our hypotheses when data contradicts our assumptions. 3I Atlas is providing data that contradicts many assumptions. Whatever conclusions emerge from the March encounter, the process of reaching those conclusions will advance our understanding significantly. If natural explanations prevail, we will have learned something profound about the diversity of objects that drift between stars. We will have to expand our models to accommodate behaviors we previously thought impossible. Cometary science will be rewritten if technological explanations become necessary. We will have learned something even more profound about our place in the universe and about what else might be out there moving through the darkness between stars. The questions raised by 3I Atlas deserve answers, real answers based on data, not speculation, not dismissal, not sensationalism. Rigorous scientific analysis of extraordinary observations. Thank you for joining me on this analysis. If you found this examination of the evidence valuable, consider subscribing to stay informed as this situation develops. The coming weeks will bring more data, more observations, and potentially more anomalies to analyze. We will be here to break down what it all means. This object has raised questions that deserve careful attention. Not sensational speculation designed to generate excitement, not dismissive skepticism that refuses to engage with anomalous data. Careful, rigorous attention to what the evidence actually shows and what conclusions that evidence supports. Until March, keep watching the data. Keep questioning assumptions. Keep demanding evidence for claims, and keep looking up, because something is approaching Jupiter. something that has already defied our expectations repeatedly. And whether it proves to be natural or otherwise, understanding what it is will require all of us paying very close attention to what unfolds.